Okay, if you write this down, you'll have the definitive guide to standing waves here. So let's go ahead and do this, right? What we want to do is we're going to do a wavelength calculation here, a frequency calculation there, and let's divide the page there, right? So wavelength, and this length here is 0.32 meters, right? So from there to there, right, it's 0.32 meters, right? And our wave speed is 281.6. And what I've done is I've tried to make this like a violin string, although I think violin strings are actually longer than that, but that's okay. Okay, so for this thing, our first one here, we're going to go 0.32 meters, right, equals 2/4 wavelengths, right? Right, so therefore the wavelength is what, 0.64, right? Okay, and then our frequency is just velocity over wavelength, right? So the frequency is 281.6. I just made that up so that it would be 440, right? So 0.64. So 281, this is meters per second. This is meters. That's meters. Meters per second divided by meters is per second, right? So 281.6 divided by 0.64 is 440. All right. Okay, so that's the first one there, right? On this one here, on this guy here, now we go 0.32 equals, and then here we've got actually 4/4 wavelengths, right? 1, 2, 3, 4/4 wavelengths, right? Therefore, the wavelength equals, well, 0.32, right? So our frequency here is 281.6, right? And that's just an arbitrary wave speed. That's how fast a ripple would move along this string, right, over 0.32, right? And that is equal to 281.6 divided by 0.32, not surprisingly, is 880 hertz, right? And now here we've got, let's see, 1, 2, 3, 4, 5, 6, right? Or by the way, 3 halves as well, right? Okay, so 0.32 meters, right, equals 6/4 wavelengths. So therefore, 0.32 times 6 divided by 4 is no, I'm wrong. 0.32 times 4 divided by 6. Okay, divided by 6. Okay, the wavelength is equal to, these are meters, right? 0.213 repeating meters, right? And then our frequency is 281.6. This is meters per second over meters, right? Meters per second over 0.213 repeating meters, right? So 281.6 divided by the answer I just got, and it's 1320 hertz. Okay. Now, if you look at this thing, this is 1 times the fundamental frequency, right? 880 is twice that. 1320 is 3 times that. That's what this thing does. It goes 1 times, 2 times, 3 times. Okay. This is, by the way, called the overtone series, and it's the basis for all the harmony and all of our scales and everything like that. So it's very, very cool. And there we go, right? So there's a lot of writing. In the next videos, I'll look at the other types of standing waves.